All right, one more example here of a proof by contradiction. So on this one, we've got given m and n are positive integers, so they're integers that are positive. M is greater than n, then m squared minus n squared can't equal 1. So they phrased it as given, it follows that, and that's the same when it says given, that's your if part, it follows that is your then part. So let's assume the opposite of then. So assume n squared minus n squared equals 1. Okay. That it can be factored as m minus n times m plus n. Okay? And what we know is we know that m is greater than n, and we know that they're integers. So we know that m minus n is greater than 0. We know that m plus n is greater than, really, it's greater than 2 because they're positive integers. And same idea that m minus n being greater than 0 is the same as saying m minus n is greater than or equal to 1. And do we see the contradiction here? This means that m minus n and m, should I put an greater than or equal to m plus n? Yeah, so they're both positive integers and m has to be bigger than n, and so the smallest possibilities are 1 and 2. So I could say greater than 2, or I could really say greater than or equal to 3. That's kind of what I'm trying to get at here. So that means that m minus n times m plus n is greater than or equal to 1 times 3, which does not equal 1. So it's impossible for m squared minus n squared to equal 1, given the if part of the statement. So that's a pretty short contradiction proof, but sometimes they're short and sweet. Let me know if you have any questions.